back to question 4 part 2, and we're looking at 4 more marks to go, so let's dive into this. Oh, it doesn't want to dive in. It's still trying to connect. There we go. Alright, so what we have here is a diagram, and they show you the size of the atom for lithium and potassium. So you are supposed to understand the electronic structure. Basically, it means how many electronic shells are there for each of them. So lithium have 2, and you can see the valence electrons is here. And potassium, there's 1, 2, 3, 4, 4 shells, and the last electrons is over there. So they start off with a 1 mark question. Instead, give one observation that is different when a small piece of potassium instead of lithium is added to water. Now, as previously mentioned in part 1 of the video, the only time you see flame is when you add a piece of potassium in the water. Basically, anything below potassium, cesium, rubidium, then it gets more and more explosive, not just flame, right? You just basically can shatter some glassware in your science lab. Okay, the understanding here is potassium is actually more reactive than lithium. So the reaction will take place faster, you get a clearer observation within a shorter period of time. So the sign here is you actually can get to see flames. If you are very clear, you can even write down the word lilac, because that's the color of potassium when it catches the flame. Okay, so that's 1 mark. Alternatively, your other answers would be this reaction would be faster, it would produce effervescence faster, the piece of potassium would move faster, it would dissolve faster, etc. So all of this would take place within a shorter period of time because potassium is more reactive. Okay? Then the next 3 mark question is a classic. Okay, I would say it's a classic paper 2 question, because this can only be tested in paper 2, right? So this is only a content that only separate science students will be exposed to. But if you are only taking double award and you are only doing paper 1, this is also a very good question for you to deepen your understanding of why exactly potassium is more reactive than lithium. So here, you need to understand that when we talk about chemical reaction is always the movement of the valence electron. And what the word valence means is the outermost electrons. So you can see that the outermost electrons for potassium is further away from the nucleus. So let's take a moment to understand. Okay, so we have got our nucleus over here. And what is in the nucleus here is our positive proton and our neutron. Okay, since neutron is neutral, it really doesn't affect us in any sense, right? So we're looking at proton and the electrons. Okay, so the electrons, I'm going to use E minus, so that you can see that, hey, I've got something that is positive in the middle, and I've got my electrons that is negative. So what is happening here is there will be an attraction. I've got positive and negative, so there will be an attraction. So for lithium, because the distance, okay, the distance between the proton, the positive proton, and the valence electrons is nearer, right? So the attraction is stronger. And I always use this analogy in my class, although my students hate me for it. It's like, if you are able to meet your boyfriend or your girlfriend in class, right, on a day-to-day basis, and you see each other on a day-to-day basis, it's like, you'll be like, I think I can maintain this relationship quite well, because I get to see this person, I get to talk to this person on a day-to-day basis at the same time zone. However, say for example, you are in Australia, and your friend is or your girlfriend or boyfriend is in America. Oh, the time difference is, okay. I'm not sure what the time difference though, but I think from Singapore to America, that's at least 12 hours. Yep. So if the distance, okay, let's look at potassium now. If the distance, the positive proton and the negative electrons, the distance is further, right, further. And what's going to happen is the attraction between the proton, the positive proton in the nucleus, and the negative electron is going to be weaker. So when the attraction is weaker, it is easier to lose this valence electron. Like long distance relationships don't last, isn't it? I mean, I went through one myself, and it lasted. He became my husband. saying like all long distance relationship would not result in something good. Okay, so I'm saying like the further the distance, it takes a lot more effort to keep the electron connected to the atom here. Let's not digress. So okay, so let's go back into the science form of things. Okay, so what's happening here is lithium has a lesser electron shell than potassium, and therefore, so this one is just basing it on the diagram. Okay, just basing on the diagram. Say for example, you have no idea what to write. You can see that lithium only has 2 electron shell, whereas potassium has 4 electron shells, right? So lithium has less electron shell than potassium. You are making a comparison here. So this one will get you your first mark. Okay, then we'll look into part 2. Therefore, there is more attraction between the outer shell electron and the nucleus. Now, this one we are focusing on, take note, we are focusing on from the perspective of lithium, right? We are focusing on lithium and the attraction between the outer electron and the nucleus attraction is going to be stronger. So you need to explain. So the outer shell is less easily lost. So the attraction is stronger, right? So it's less easily lost. Therefore, lithium is less reactive than potassium. So if you can pause for a while and understand here, being reactive basically means how easily the electron is being given away, how easily the atom is willing to lose its valence electron. So in this case, because lithium is able to hold on to its electrons so tightly, it is not so reactive because the electron stays within the atom, is not given away. Okay? Of course, you can word it in the opposite manner. You can word it in the perspective of potassium being more reactive because it is willing to lose its valence electron more easily because the distance between the proton and the valence electron is further away. Okay, so that is another way of wording out your answer. Give it a try. If you find that you want to word out in your own ways and you're not sure whether you can hit 3 marks, this is a full 3 marks here, feel free to just drop it in the comment or just DM me directly on Instagram, and yeah, I'll be happy to check your answers for you. Okay, now of course we're going to take a moment to look here. Okay, these are things not to write because these are common misconceptions that students tend to make. Right, now one thing to take note here is for group 1 metal, this one to take note. Okay, I'm going to put it here. Group 1 metal only contain 1 valence electron. And what this means, and how do you know, and how do you confirm, is you can use the diagram. Both of them only have 1 valence electron, and that's the reason why they are parked under. You will not score. You will not score the 3rd mark if you put electrons. Basically, you're not supposed to put the plural form of electrons because there's only 1 valence electron in the last shell. So if you put the word electrons with the S, unfortunately you will not lose. You will not get your 3rd mark because there's only 1 electron that is being given away. Okay, so take note. There is only 1 valence electron. If this question is changed to like group 2, then that's fine, right? Because group 2 has 2 valence electrons. So take note of these small things, and in my opinion here, this is one of the rare times that they are quite strict with singular plural grammar over here. But then again, it really ties into your understanding that here we are talking about group 1 metals, and they have stated and emphasized this right in the beginning of the question. So please take note of all these things. If all things fail, then the diagram here is supposed to give you an anchor, give you the context that you are only dealing with the losing of 1 valence electron for when you discuss reactivity. Alright, so with that, hopefully it's not too tedious. And if you've got any question, feel free to drop me a DM. If you want me to check your answers on how you will word the 3-mark question, feel free to drop me a DM. If this has been helpful, please don't forget to like and subscribe. Alright, see you in the next one.